So we have equality in first order logic formal deduction, and basically we have these 5 items. We have 2 primitives that create these 3. The proofs are proven in the slideshow here, but that's beside the point. All we need to know is that we can use these to create these, and we're given these 3 on our formula sheet here, and we can use these on our exam. So where is it? With this practice tutorial, we want to prove specifically, given no assumptions, t equals t for any t, that t1 equals t2 deduces t2 equals t1, and that t1 equals t2 and t2 equals t3 equals t1 equals t3. So it deduces t1 equals t3. So these are reflexivities, symmetry, and transitivity. And it may seem like this is using the proof to prove the same proof, but it's actually taking the for all statement and turning it into the specific one. So how do we do this? I'm going to focus on notation. So we do formal deduction style, where we have 1, 2, 3 on the left. We have our assumptions on the left of the deduction sign, and we have our items on the right, and we cite what we did. So for this one, reflexivity, we have no assumptions, proving u equals u. Where's this from? Also, that we use this equal sign interchangeably with the equal sign that looks like this. The same thing. So where is this from? It's this one. Equals plus. And it's a primitive, so we can just bring it in. And then we pull out this one, which is reflexivity from the formula sheet. And we say it depends on 1, and we use for all plus to get this. And we also have to say the statement u does not depend on our assumptions. Doesn't make a whole lot of sense to me because this seems unnecessary. Our assumptions are nothing, but it does not depend on our non-assumptions, I guess. And then we reach what we wanted to reach, which is t equals t. We essentially turned u into x into t using for all minus. Now, symmetry for equality of terms. How do we do this one? We pull out this. Oh yeah, I should cite these. This is where's this from? Oh yeah, we just cite transitivity of equality, and then here we take away the for alls. I believe that should be times 2 because there's 2 for alls, and we get this stuff inside. We replace x and y and x with the 2 things we decided to remove the for all with. That is t1 and t2. Then we keep exactly the same right hand side. But we add t1 equals t2 to our assumptions as follows. Then we use the assumption and change the right side to use membership from the original question. And then we keep the same assumption and we activate this if statement, and we activate this antecedent to give us the item that concludes from it. So that's implication subtract. Last but not least, for transitivity of equality of terms, we're given these two items, t1 equals t2, t2 equals t3, deduces t1 equals t3. And what you should immediately think of is that we're going to at some point turn this into an and. But we'll keep that for later. We start off by introducing our formula from the sheet, transitivity of equality, and then we take away the for all, see the times 3, and we replace it with our t1, t2, and t3. Then we introduce these two givens to our assumptions, and we keep the right side the same. Then we pull these out individually as membership, and then the step in between, the real 6, should be that we have t1 equals t2, t2 equals t3, deduces t1 equals t2, and t2 equals t3. We should have gotten that, so that was my bad, I didn't add that. And then 7 would be this, where we take this and we take, step 3, which says given the and, we get this, in order to arrive at the conclusion that we wanted.